Hello, my name is Clemente Mena, and today we will attempt to do a thermodynamic problem of mass flow rates. As you can see on the board, I have written out the problem, and it states as following. A water tank initially containing 200 kilograms of water is being filled. Water is leaving the tank through pipes 2 and 3. The flow rate through each pipe as a function of time is given below. The mass flow rate of 1 is equal to 0.4 t plus 5. The mass flow rate of 2 is equal to 0.1 t plus 4. And the mass flow rate of 3 is equal to 0.2 t plus 3. And those are the three functions of our inlets and exits. The question states as follows. Determine the time it takes to reach a mass of 250 kilograms in the tank. So if we draw a quick sketch here of our tank, we see that we have flow rate into the tank. Here's our tank. And we have two exits. So this is flow rate 1. Here we got M1. We got M2. And we got M3. And in which these correspond to the different equations or functions. So we have our water tank in here, and we want to determine how much time it takes to fill it up to 250 kilograms. Therefore, our mass flow rate equation is going to be the following. The mass flow rate of the control volume, which is our control volume right here, is with respect to time is going to be equal to the summation of the inlet, the mass flow rate of the inlet, minus the summation of the mass flow rates of the exit. So with our equation, now we can go ahead and solve our problem. We know that our mass flow rate of the control volume with respect to time is going to be equal to the function of the inlet, which is this one, inlet. And then we know that pipes 2 and 3 are leaving the tank, so they are actually draining it, so these would be our exits. And this would be our inlet. So then we come back over here and plug in our function 0.4t plus 5 minus 0.1t plus 4e, oops, just 4, minus 0.2t plus 3 plus 3. So at this point, we just go ahead and solve by combining like terms. Here we got this one, and this one. So 0.4 minus 0.1, we get 0.3. Minus 0.2, we get 0.1t. 5 minus 4 is 1. Minus 3, negative 2. So our equation, the difference in the mass of the control volume with respect to time will be equal to this function. At this time now we can go ahead and take the integral of this equation as well as this with respect to time. Therefore, we have a change in mass of the control volume is going to be equal to the integral of our equation, which previously done, we can get the calculation, which I have already done, and our calculation comes out to be negative 1t squared over 2 minus 2t. So at this point, we go ahead and solve the change in volume. So our change in volume was originally 200 kilograms, and then we wanted to end up at 250, so it would be 250 minus 200 is equal to our 0.1 t squared over 2 minus 2t. At this point, we go ahead and solve for t. So we end up getting 50 is equal to 0.1 t squared over 2 minus 2t. Solve for t, we end up with, as I previously calculated, a time of 57.42 seconds. And this is our answer here. This is the time that it would take to fill our tank to a mass of 250 kilograms.